Okay, so in this video, we will discuss informally the idea of a permutation and or rearrangement of the natural numbers. Both words are interchangeable as they're synonymous of each other, and whether we include or exclude 0 in the set of natural numbers is not relevant in this discussion. So what is a permutation and or rearrangement of the natural numbers? Well, all it is a function, which I will call sigma. This is the Greek letter called sigma, and the permutation and or rearrangement of the natural numbers is a function from the natural numbers to the natural numbers that has the following two properties. And again, I will be informal about this, but the name really gives it away if you think of rearrangement. All this function does is it will shuffle around the natural numbers. So imagine that you have the following picture for the situation. So you have here the natural numbers. We apply our rearrangement, sigma, and we get back to the natural numbers. The first property states that distinct natural numbers will be sent by sigma to distinct natural numbers. So if we take the natural number m and the natural number n, and they're both distinct, we look at their image under sigma. So m is sent to sigma m, n will be sent, of course, to its image under sigma also, which is sigma n. And the first property is just that. If m and n are different natural numbers, so if they're not equal, then their respective images, sigma m and sigma n, which are also two natural numbers, will also be different. So different natural numbers are sent to different natural numbers. The second property is that every natural number has a pre-image as some natural number. So if you pick any natural number, say n, this is the second property, there must exist some natural number m where m will be sent under sigma to the real, not the real, but the natural number n. So n equals sigma of m. And those are your two properties in order to call sigma a permutation and or rearrangement of the natural numbers. So all it does is it shuffles the natural numbers around. Distinct natural numbers are sent to distinct natural numbers, and every natural number has a pre-image. So you can imagine, very simply, balls numbered from 1 through infinity, and just picking at random one ball after the other, and what you would get would be the exact same set, but in a different order, which is why we use the word permutation or rearrangement. Let's look at an example of what this may look like. Suppose we list, say, the first 7 natural numbers, so 1, 2, 3, 4, 5, 6, 7, and so forth. We apply our rearrangement sigma, and suppose the rearrangement is the following. We will list the first 2 odd numbers, then the first even, then the next 2 odd numbers, then the second even, and so forth. So 1 will be sent to sigma 1, which will take to be itself 1. 2 will be sent to sigma 2, which we will take as the second odd number 3. So we've listed the first 2 odd numbers, 1 and 3. But then we'll squeeze in here the first even number. So sigma 3, the third element of our list, will be 2. And I will jump back to the next 2 odd numbers. So the fourth and fifth numbers in our list will be 5 and 7. So sigma 4 is 5, sigma 5 is 7. And then we will pick the next even number, which is, let me include 5 and 7, we've picked those two. And then we will take the next even number, 4. So sigma of 6 is 4. And so on. And you can see, really what we have is a simple rearrangement of the natural numbers. If you list them in the initial order, 1, 2, 3, 4, 5, 6, 7, 8, and so forth, and now we list all the natural numbers exactly once, but in a different order. 1, 3, the first two odd numbers, then 2, the first even number, then 5, 7, the next two odd numbers after 1 and 3, then 4, the second even number. If we kept going, we would have then 9, 11, then it would be 6, then it would be 13, 15, and 8, and so forth. And this is our rearrangement. Now you may ask, well, what does this have to do with the idea of series? Well, we will look in our next video at the so-called rearrangement theorem, which will involve the idea of a rearrangement of the natural numbers. So all we're going to ask is the following question. If we have a series, what happens if we sum the terms in a different order? If we perform a rearrangement of the series? And as we will see, the answer is not so obvious.